Rails, and this is the first time I'm giving a presentation. This is the first time I've wrote a presentation talking about. Basically, I'm trying to augment what Colin already talked about, and I think basically what he left is really stuff that you probably already know related to how like tables work, but then it's basically Barrage. So it's mostly background, getting to talk about Barrage, and then just briefly throwing in kind of like the things. So
okay, assume nothing.
Yeah, so ask questions. Let's make it interactive.
Yeah.
Ryan will keep us on task.
To be fair, actually, what I said to Nate was that I specifically wanted to find out about or experience firsthand was how deep the questioning went, because I'm kind of curious as to how this feels to relative outsiders for it, if you know what I mean, right? So that was what I wanted to experience firsthand, let's say. And I'm going to be here in the background, muted and off video.
Yeah, the comments I got on Colin's presentation were along the lines of it was drinking from a fire hose.
Yeah. So, yeah. Well, hopefully I tried to aim for a good level of detail, but if I'm too detailed or not detailed enough, just ask questions. Can everybody see the presentation? Okay. Excellent. So, table, this is from a 10,000 foot view, is basically, it's an index of what rows exist. It's basically an ordered set of non-negative 64-bit integers. It's also a map from column name to the actual column that stores the data or that can actually compute the data. I guess we can also throw in some attributes, not super relevant to this conversation, and then the fact that there are listeners and there's an update model for ticking tables. So briefly, kind of like this is how, this is the first hook in is basically a root table, which we call live tables. Live tables don't actually have to implement the table interface, and they really only have this one method, which is this refresh. Anything can ask the live table monitor to refresh a particular live table monitor, but I believe the common pattern is there's something that's either looking for data on disk or it's coming off the network, and it tells the LTM, hey, I basically have an update that I need to apply and let everybody know about. And then the LTM's job is basically when the tick starts, it goes into basically an updating phase. And I believe it refreshes one live table. There may also be a variation that refreshes all the live tables inside of a single tick that are outstanding.
That's the standard now.
That's the standard now? Okay. And then basically each live table, so the live table monitor can execute the work that it needs to do in parallel, as long as for each piece of work, any of the dependent work is already satisfied. So in this case, if there are multiple live tables, I would expect that each of them could be refreshed in that pool independently of each other, because they can't depend on each other. They're sources. But you might have like a merge operation lower in your DAG of operations that takes a bunch of live tables and merges them together. So it has to wait for all of those to finish their update for that particular cycle before the merge can go. And yeah, and then basically
So you said the live tables were all sources?
I believe that they are. I mean, they're sources to the live table monitor, right?
Okay.
Are you confused by me saying that?
Well, I'm just trying to understand if you're saying that they have to be roots of the DAG.
They don't. Okay. Yes. So as far as the LTM is concerned, they are roots of the DAG. Technically speaking, they could receive, data. You could have a cycle from, the output of your DAG that gets inserted to the live table this way. But as far as the LTM is concerned, this is supposed to be a root for any form of computation. Did I clarify your question?
Yeah.
Okay. All right. Are there any questions or comments about live table monitor?
So you said all of this merges at the very end. So this is really saying like there's only one live table monitor, so it refreshes that one table that's the root every single time.
There may be multiple roots. So you could get data from multiple exchanges over multiple sockets, create multiple live tables, right? And what I meant by that merges in like the table operation. So you could potentially have an operation that takes multiple sources and performs an operation onto them to create an output result table.
Okay.
Does that make sense?
Yeah.
Okay.
The other key example there would be join.
Yeah.
All joins. They have two sources.
Yes. That's correct.
Yeah, and Amanda, there's one live table monitor for everything.
Yeah. Oh, yeah. But that is,
For now.
let's try not to rely on that. That is a symptom, I think, of choices that we've made over time, and I think there are some benefits. And obviously, this is Ryan's choice and the direction of the entire team. But in general, it would be nice to not have a static LTM that we depend on. It makes it difficult to run tests in parallel. It's easy to have state leak. We've spent a lot of time on those kinds of problems. And it would be nice maybe at some point in time to have two separate LTMs, one that kind of has a slower clock cycle and one that has a faster one. So one that's kind of like reacting to like a greater, I'm going to recompute my Black-Scholes algorithm a little bit more slowly, but still on that same host, I want to be, taking whatever is output of that and execute orders or something. I don't know. It might be nice. And technically speaking, we do have live table monitor to another live table monitor based transfer of data. And that's what Barrage is. It just happens also to be over worker to worker. So, all right, let's talk about the table update model. So I basically decided just to talk about the shift aware version of this. There's technically a non-shift aware version of this, but it's almost gone. There are very few operations that use that model. So I'm just going to talk about this one. The main difference is that this one has shifted and modified column set, which I'll describe momentarily. So the table update model basically gets this class object, which I have here on the right, and it describes which rows were added in a particular update, which rows were removed, which rows were modified, and then this modified column set describes which of the columns were the ones that were modified with that modified index. So it's kind of like, it's like an additional filter. So it's not just the rows that have changed, but also only these columns. This allows a downstream operation to like a filter to say, oh, the column that I care about didn't change, so therefore I don't actually have to do any computation. It's kind of nice. And then the second feature that's part of the shift aware version is the actual the shifting of rows. So this is a good time for me to talk briefly about key space versus position space. So key space is what this index object usually represents. If you ask a table what its index is, it's talking about key space. And the point of key space is to be able, for a computer to say, this is exactly where in memory this data is. And then the position space is kind of, if you think about the table in the UI, right? You don't see gaps between rows, even though there are often gaps between rows intentionally to support, the intents of an operation. So, for example, sort is a really important operation. The order matters, right? It's defined as doing the sort, right? So the data, when you sort it by, let's say, symbol, you're expecting things to be in that order. But if you've got a ticking table, you need to occasionally be able to stick stuff in the middle of things. And so, if you think back when you learned about arrays and array lists, insert in the middle of an array is actually really expensive and ends up being like O(n squared. So sort tries to keep gaps between rows, and it does a little bit of a balance between gaps and runs as well for other, to kind of like compact all the state that it needs to keep track of. But sort keeps these spaces so that it can insert stuff in there without paying an O(n cost on the size of the table. So shifting enables sort and other operations like merge to move data out of the way to make space for data that kind of belongs there when the ordering matters. And then because of this shiftedness, you might see on the code on the right that basically the modified and the added indices are in the post-shift key space, and removed things are in the pre-shift key space. So you might remove things and then shift stuff around, and then write in an area that used to have data but is,
Is this
doesn't
all
anymore.
behind the scenes, or if we know
This
we're
is-
going to have a really moving table, can we insert more shifts to accommodate?
So it's both. So so this is I'm in a sense trying to lift the veil of what's happening in the engine, because it informs what we need to be doing on the API side. So if you create a listener and you want to attach some conceptual idea to a table, you want to effectively operate on the state that it currently has, and then whenever it has future updates, you want to modify your state while it's happening. So suppose you wanted a computer running sum, right? That's a pretty simple example. So you would effectively go through and fetch all the data in the table for that column that you're computing the running sum on, compute the sum, and then later, whenever you get the updates, if you see something that's modified, you'd go read the previous values, you remove the previous values, you read the current values, add the current values, similarly remove the old values for removed and the new values for added, right? So if this is the kind of thing that we're going to be covering in the DevRel blog, then this is absolutely important information that somebody will need to understand enough to write a blog post about, right? That said, most of this is hidden by our table operations and also by the actual gRPC API. Does that answer your question?
So, from the DevRel side, the most common time, a user would deal with this is for creating a listener to a table. So the listener is going to receive one of these update objects here, and that update object will indicate, what's actually changed in the table. So, if the listener is going to send a Slack message every time something happens, it would say, okay, a row got added. Let me go pull the data from that row and create the Slack message to send out. Right? So Nate, can you speak about I and K in the query language before we go on?
Yeah. So there are a couple of custom things inside of the query language. So the one actually, I know there's lowercase I, there's lowercase double I, and then there's lowercase, it sounds like there's lowercase k. The only one I use is I, which basically tells you what that key space is for a particular row. But that being said, those variables we're trying not to use anymore because of the shifting. So the shifting doesn't actually, there are some operations that if the previous value doesn't actually match the real value, then the operation ends up, even just throwing an exception, like not even just computing something wrong, which would happen in my running sum case. Sorry, not running sum, but just the aggregating case. But yeah, does that?
Just to, not sure, but just to clarify the answer to the question, I is position from zero index position of a row as an int. I is zero index position of a row as a long. It was necessitated by trying to keep old code working while also allowing sizes greater than the maximum integer in Java, maximum signed integer in any language really, 32 bits. K is the index key for a row. And I think what Nate was saying about not using them, they have a very important use case, especially I and II for kind of array dereference within an expression. They are not safe to use against any kind of ticking table unless that ticking table is flat and add only, effectively speaking, that it's append only and with no support for shifts, no support for data movement at all, right? There is an attribute you can set on a table to assert that something is add only.
So is K safe in a way that I is not?
Not really, in the sense that you won't be advised that K changes. If you were to depend on it in an expression, right? You could write custom code that would react to K changes by looking at shifts, right? But that's about the only option you would have there.
Right. And it would be expensive to build that into the engine, like to encourage people.
That's
to
right.
do it. Yeah, which is
Very, very expensive.
right. Which is the main reason we're not doing it. Okay. All right. So that's a high-level overview of the table update model. So let's think about the table update model with respect to this idea that the LTM has this updating clock cycle. So I've already mentioned briefly like this idea of prev and cur, but I'm going to try to formalize that a little bit more on this slide. So some of the guarantees that we want, or yeah, I guess the guarantees we expect is basically during an LTM update, there are three things that'll be true for, or one of these three things should be true, or maybe two of them, whatever, for a table. Either the table's not going to update this cycle, or it's going to update after its parent / upstream dependencies have updated, or the table has already updated this cycle. So while the table is updating, basically the cur values of the table are changing. They're changing from underneath you, if that makes sense. So if you're outside of the LTM and you're trying to read data, if you're reading cur data while the LTM is updating, you're not going to see a consistent snapshot or you're not going to have a consistent view of that data. So we have this idea of prev data. Well, actually, yeah, prev also has a value on the LTM. I guess I'll talk about that too. But so you can ask for the prev values, and the prev values will tell you what the table was at the beginning of that clock cycle. So the current data is basically only valid if the table has already updated this cycle, or you're not in the middle of an update cycle. And then the prev data is only valid during the middle of an update cycle. Because when it's on an off cycle, that's when we actually update the prev data to the new cur.
You could also state that current is also valid if the table will not update on this cycle, and you can prove that.
If you can prove that. I don't think, yeah, may not be.
Satisfied dependencies would do it.
Oh, yes, I see what you're saying. Got it. Okay, yes. Okay, so if you imagine the scenario we were talking about, creating that running sum, you kind of need to read the existing data and attach a listener at the same time, and you need to see that consistent view of data before getting your first update from that listener. Otherwise, you're going to be really confused as this listener. So we have this concept called concurrent instantiation, which attempts to read the data using the prev or cur based on the current rules of where the clock is, and it tries to do this without preventing the clock from ticking. If the clock happens to tick underneath us, or the table that we're looking at changes underneath us, then we will restart that. And we'll restart it a few number of times. I believe the current number is 3, may be configurable as well. But when that fails, then it'll hold on to that exclusive lock, which prevents the LTM from updating. And so you can simply just ask for everything current, and you don't have to worry about the actual race condition to actually get what you need.
This might be a
It
stupid
only
question.
needs a shared lock.
What determines the LTM cycle time?
So the LTM cycle time is determined by effectively the longest length of computation that is dependent on each other.
There's also a target interval that's expressed via property and can be reset at runtime. I think the default is 1 second. So, if your LTMs are longer than that, then that's how long they're going to be. If they're shorter than that, then they're going to be that target interval.
Okay.
Right.
Yeah, and that'll come in for performance analysis as well. So you can see, are you taking more than the target time or what have you?
Mm-hmm.
So Nate, if you don't have a slide on it, can you discuss the different types of locking?
Yeah, I probably will need Ryan's help. But my understanding is LTM has a shared lock and an exclusive lock. The shared lock is basically a multi-reader lock that prevents the LTM from ticking while it is being held by a reader. Does that sound correct, Ryan? Did I say that right?
That's right. So the idea is you can have multiple concurrent readers acquiring shared locks. whereas only the LTM or something that wants to block everything else from functioning would use the exclusive block. It's a reader. It's basically it's a kind of a slightly fancy reader's writer's lock.
Right. And then I mentioned briefly the cur versus prev, that this isn't the only intended use. It's actually intended to be used as a listener when you receive an update and you were previously already in sync with the table. You can ask for what the prev values were for modified values and removed values. This is how you can actually compute that, the aggregate sum that I was explaining. Okay. So in the last presentation, Colin mentioned that I would talk more about stuff. I don't think there's a whole lot more to talk about those things, but it is worth discussing for anybody who has questions about them. So the first one is basically the console service and it holding on to the LTM lock. I believe it holds on to the exclusive lock. And I think the main reason is if you're thinking about the end user who's sitting in front of a script session, he writes a little bit of a script. If he goes and fetches data and then he makes a decision based on the data that he fetched, it would be nice if he recomputes exactly the same thing that he would get the same value back. So we have this expectation, or we expect that users are going to have this expectation that the tables are not ticking underneath them while they're inside that same script block. Does that make sense? And do you think I covered what Colin claimed I would cover?
I guess it doesn't totally make sense to me.
Okay. Can you help me highlight what isn't making sense about that?
Okay, so what is the console service just executing a block of code?
So yeah, well, the console service is a gRPC service that is being backed by a couple of things, but one of the particular functionality that we're caring about is the script session, right? And so script session has an evaluate script method, which takes a block of text, and so in the web UI, what you type in that little box ends up running in that evaluate script method, and so inside of that little block that gets compiled, or it could be big block, or whatever, that gets compiled and executed, we're holding on to the lock. So if you call like get chunk at the very top, and you call get chunk at the very bottom, the data that you're going to get back, if it was the same table and the same ranges, is going to be the same data.
Okay, but from a practical perspective, does that just mean that everything is frozen until that script executes through?
Yep.
Okay.
But the key here is that everything is completely consistent throughout the execution of the script.
Right.
And you've seen it before. If you want to write things that will that depend on the LTM ticking to make progress during the script, you need to use condition variables that are LTM sensitive. Every table has one, right? So that you can wait for changes.
Right. And the alternative here is, if you don't want that kind of behavior, if you want something that's a little bit looser, then I think that's where the Java API and the other APIs come into play, because they are a little bit more flexible. They use the gRPC table operations that Colin was talking about that depend on each other and create a queue, and basically it's very explicit about what the expectations are. But I think in a script session, or especially inside that little block, I think it can be especially confusing to people who don't understand, that, for example, join requires all of the tables that it's joining to have already ticked this cycle. And that's where the exclusive lock comes into play. You can guarantee that the tables have ticked. There's no ticking going on, right? But otherwise, that knowledge would have to be known by the user for the script console or the console session to behave any other way. Okay, and then the second thing, I actually don't think that he mentioned it in there, but since it came up in the chat in the team chat this morning with Amanda, thought I'd mention briefly why we're having a single REPL. So in the script session, we're having a global single script session right now because there are 3 static global contexts: the query scope, the query library, and the compiler context, and they all use thread locals, and they all they don't necessarily you aren't required to necessarily release the thread local that you get. So there's a global value that's set, and then the thread local may effectively like hold on to it forever.
I'm not sure what a compiler context is. Could you back up for a second there?
Yeah, so the compiler context, so if you go back to the script session, when you create a new class in a script session and you run it, you can use that script, you can use that class in like a formula, like in an update formula. And so the compiler context helps the update formula find the particular class that you defined in the Groovy shell earlier.
Okay, is there an equivalent for Python?
Yeah, the Python also has its own compiler context, exactly. And so these, yeah, go ahead.
I was just going to say, it's really about Java classes that have been loaded, as well as providing caching for previously generated formulas and conditions.
Yeah, it's also the ability to overwrite things, right? So even though there's caching, it's resilient. It doesn't require the work to be restarted if you want to redefine a class that belongs in a formula column, for example. And so there are a couple of places that kind of like, for example, if you created a listener and from your listener you decided you wanted to create a table or instantiate a table, which I believe is something that Rob has done, for example, on his pivot widget, then the query scope, the query library, and the compiler context in a multiple script session scenario would not properly be set there. So there's, those three things aren't set with the right context in the different places that they would need to be. And it's a lot of work. And then on top of that, we'd have to explain to users that if they choose to offload some of this work to a thread pool, that they also have to follow these rules. Otherwise, they may not get kind of like what they're expecting. I know that's probably not like a very satisfying answer as to why we're having a single script session and why you can't do both Python and Groovy in the same worker. But if you have any complaints, now's the best time because Ryan can help defend.
Well, I thought that there were two separate workers when you have the two separate sessions, but they're on the same localhost port, so that makes total sense. And
right.
Yeah, it's exactly one JVM, and there would have to be some engineering work to get it quite right in terms of these different contexts that we've decided to postpone for now because we don't have a strong use case for multiple sessions.
so I was misinformed before because I thought only timetables used LTMs, but really all tables are using this behind the scenes, right?
If it's not a static
All
table,
updating
absolutely.
tables.
Yeah, exactly.
All updating tables.
But you can
So a
update
timetable, no. So not update in the sense of like the table operation that adds columns. Updating meaning their data can change, right? So timetables would certainly have a live table that's a root node in the DAG and be updated as part of the live table monitor. On the enterprise side, all of the persistent intraday data would have a live table with a source node in the DAG. That's the source table tool. Those are the two main cases, right? We're going to be adding live Kafka tables probably next month in OSS. And I mean, obviously anything else that you want to build. So for example, I think you were talking about building a case where you would scrape a website, ingest the data, and then have basically trigger changes using the live table monitor, if I recall correctly, right? So that would be another example, another use case.
Yeah, so you can imagine that your query can be represented as a directed acyclic graph, but part of that graph is dead because the tables are historical and non-ticking. So we don't care about updating that part of the graph. So then the live table monitor is handling the locking for the updates of the part of the DAG that is active.
So let's take a step back and let's think about we've been talking about the update model with respect to a single worker and a single LTM, but a really nice goal of the gRPC API is to shove that data from one worker to another worker. This IPC and the title stands for Interprocess Communication, and so basically we want to exchange data from one machine to another, or one process to another. We want to try to avoid security vulnerabilities. It's natural, so we don't want to have make it really easy for an external client to create a bunch of resources that get stuck on the worker, right? Stuff like that. We don't want to. We kind of want to avoid doing the Java serialization, which we were doing before. A nice benefit of kind of getting rid of the need to do Java serialization is that we are likely to be more compatible with other languages. We also want to batch bursty data. If the same row changed 100,000 times within a second, it would be nice if we just send like the most recent version. And then in terms of the avoiding redundant payload, the idea is, from worker to worker, we have to send the real data. So it's nice if we, before I mentioned that the modified rows in an update are basically modified multiplied by the columns that were actually changed. And so if we're batching bursts, you might get multiple updates where you've got different modified rows that touch different sets of columns. And so we only want to write down the data that actually changed. And so that changes a little bit that payload that goes from worker to worker versus the other update, the existing update model. Okay, so kind of what is Barrage? Barrage is an extension of Aeroflight. It has a very similar update model to the table. Again, so for modifications, there's a modification index per column that will change. The update model includes the data payloads because it's going from one machine to another. So we actually have to ship the data. We have to write it down and send it over. And then it also supports this concept of viewports. So I mentioned, minimizing the data. Well, if the user only wants to look at this little rectangle, it's nice to have a little API that shows you just that window. And so those are kind of the goals of what we try to do. So, all right, so let's take a step back and remind ourselves what Aero and Aeroflight is. I know that you talked about this already, Chip, but Aero actually just changed their bite of what they are. They call themselves a multi-language toolbox for accelerated data interchange and in-memory processing. Apparently, Wes, who's one of the original founders or owners or authors, whatever you want to call him, he says that it was really damaging to them to be called a data format, and so that's kind of interesting. But the thing that we really care about is the data interchange piece of this. We want to try to be compatible with as many other data science tools as possible, and this seems to be the most promising. In terms of the thing that Wes hates the most, it is an efficient in-memory storage format. It is supposed to be ideal for computation, and it is meant to be shared so that you don't have to transform the data, leaving a process and going into another process when, supposing, if the two processes are on the same machine, they could use shared memory instead, and stuff like that. So, but even just removing the transformation is a significant cost when you're talking about, terabytes, petabytes of data in aggregate. So Aeroflight is an API that's over gRPC. It is not quite like gRPC in the same way that Colin talked about gRPC. So there are three methods, the doput, the doGet, and doExchange methods. And similar to all other gRPC methods, they have a protobuf header, but that's about like the only thing that is in common with the rest of gRPC. So inside of that protobuf is a field, I forgot, I can't highlight. Can't remember the name. It might even be just like app header or something. But it describes the payload that comes after the protobuf. How many bytes for each column, which columns are there, what are the, earlier in the stream, it talks about what types the columns are, and so on. This protobuf header also has an app metadata field. You probably have heard me talk about it over the past month or three, because this is the best way for us to integrate with Aero and minimizes the amount of of API changes that we need to give to Aero or to any other client library of Aero that we'd like to use. I mentioned this word flat buffer. So protobuf is a similar technology to flat buffer, except that flat buffer is it's effectively can work like a C struct. Like it's made to be really efficient in C or C++. And that's the only difference in the buff. I don't know. I don't really understand why they picked using flat buffers there, unless maybe Flight was tacked on after the fact. gRPC technically doesn't have to use protobufs. It could use flat buffers. So I find it a little surprising that they didn't use flat buffers. But this is where they are. So it's got a couple of layers deep. Colin enjoys complaining about how many layers of things are needed.
Sorry, quick question. Sorry. Is everyone that's using Flight also like de facto inheriting the use of gRPC?
Everybody who uses Aeroflight has to use gRPC. Yeah, that's correct.
Okay, so gRPC came first, and then Flight came on top afterwards.
That's correct. Yes, and I believe both. I think Aero also came before Aeroflight. So I think they already decided to use flat buffers because it's C++ friendly, and because the in-memory storage format for Aero is C++ friendly. It seemed to make sense. But then I'm guessing that was probably like, well, how do we make Flight work and look like gRPC? So I think the idea is there are some, so those are the only three methods that do this. There are other gRPC methods that use real protobufs. So I think they're just kind of trying to compromise.
Thanks.
Okay.
So does that imply some inefficiency with protobuf and memory layout?
I want to say there is inefficiency. If efficiency is the thing you're trying to totally squeeze out of the lemon, but so the thing that they're really trying to get right is this consistent end memory storage. So they're willing to pay a little bit on the metadata and that cost to go for bandwidth. So yes, there is a little bit of overhead that say even gRPC gives us. So like Colin mentioned, it speaks HTTP 2.0, and that means that every message gets sent has like a blob of headers that identify them. So really small payloads that get sent have a relatively large header. But if your goal is to send a lot of data, then that header gets kind of squashed and sent away. So
right. I was specifically asking protobuf versus flat buffer.
Oh, yes, it's actually cognitive header, in my opinion. So, well, even the flat buffer is a little bit difficult to use, but both like the API is a little bit cumbersome. So protobufs, actually flat buffers too, they're both immutable. So they require like this construction, flat buffers have to be constructed such that everything that you depend on is built before the thing that you make, because they get, you constantly prepend the information in the flat buffer. The protobuf is a little bit different. It has like, whenever you write a field, it writes down a tag, which I think is a pair of bytes, or maybe it's 1 byte. I think it's a pair of bytes that describe the field, so what the type is and how large it is, so that even if the reader doesn't know what that field is, it can skip over it. Flat buffer doesn't have that same kind of guarantee. Yeah. Does that answer your question? I think it does.
Sure, I may want to read more.
Yeah, there are inefficiencies, right? Because you're using 3 different things to parse it, right? You have to parse the protobuf, and then inside the protobuf has a byte array, and then you have to cast this byte array to a flat buffer. In Java, it's a little bit of, you have to translate it because you can't use the C structure. In C++, the flat buffer can just be like reinterpret casted, right? So
right. Yeah, it's just, so flat buffer is just a chunk of bytes.
Exactly. Flat buffer is, I mean, they're both just a chunk of bytes, but the flat buffer is a chunk of bytes that can be read without further interpretation, especially in C++. An idea. Yeah. And then basically after the protobuf header is where that actual Aero payload follows. So most gRPC calls don't have anything after the protobuf. So what that means is that every implementation that pulls data after this protobuf needs to integrate with gRPC in a custom way. So, we did that in a way very similar to how Aero did it for their Java client, but we couldn't use Aero because Aero, like Java Aero, is backed by their own version of chunks or their own buffer, their own buffer thing. But hopefully, and we're trying to do this with the C++ API, but hopefully for all of the other languages, we can use Aero's implementation of Flight, which may help get rid of, because it was a little bit of a pain to do all the things that they did in the Java library. And I think the Java library is probably, for gRPC, is probably the easiest to use out of all of the gRPC libraries. Yeah, so it would be nice if we don't have to do that, if Arrow's already going to do that for us. So what does that mean for Barrage over Flight? Again, we're going to stick our app metadata into the record batches field. Record batch is a flat buffer, so it's like a flat buffer inside of a flat buffer. Or actually, sorry, that app metadata is not in the record batch. It's actually in the flight data, and the record batch is the other header. I just wrote the wrong thing there. It's broken into basically K batches for adds and K batches for mods. Arrow basically doesn't have a way to say that I'm going to send these columns twice. So I can't just send, here are the add columns and there are the mod columns. And then on top of that, to be friendly to images, they also have a limit of 2 to the 32 number of elements that can be sent for any particular column in that payload. So right now, we're only going to send one batch and one add batch and one mod batch. But eventually, when we want to support more than 2 to the 32 rows at a time, we're going to need to be splitting it up into K, whatever K is. Probably something smaller than that. The multiple of these record batches get accumulated, and they would get effectively pushed through this Barrage source table. So that's the name in Java, but it could be any custom listener. The Barrage source table takes that the Barrage version of the update model and converts it back into the local update model, and then feeds its local LTM. And then I mentioned on the last slide, basically, like, hopefully the approach, the thing that we're betting on in this approach is that hopefully we can use Arrow to do most of the heavy lifting for the wire format. And that's everything that I was able to throw into the presentation. Looks like good timing.
Okay, can you say something about types and the us using Arrow as the wire format, and how we may basic types are simple, but as soon as you get into strings and other things, what does that mean?
Yeah, so Arrow supports a bunch of types, and because it's an open source project and has been living for a while, it even supports types that don't make a lot of sense or are sometimes very similar to other types. So we support a very small subset of Arrow right now. And on top of that, it would almost be fair to say that we don't support Arrow. We only support things that we write out, because we also add a little header that says this is the type that we're expecting it to be. We're going to get a little more flexible with that, but we haven't needed to be more flexible. But in general, all of the chunk types are supported, right? So primitives, longs, doubles, all of those types. Arrays of primitives are strings, they're not primitives, are also supported. They're basically var, char, arrow types, okay? And then the remaining objects that we don't know how to serialize right now are auto-serialized as strings. There has been a little bit of a conversation recently between Charles Collin and others here as to whether or not we should be auto-converting to string, or if we should be doing that only when we know we need to. So the reason we're doing it automatically right now is that the web UI client was the only client we really cared about, and for any data types that it can't display, we might as well send something that's useful for the user, because a string is going to be useful anyways, right? It's not so useful like you build this big script and then you try to connect to a table, and you can't actually see that table on your in your UI because it has a column that doesn't have a type that's supported, right? Then you have to go find, okay, where's the table? I have to go remove those columns. Even when it was failing for John Feng, it was really annoying for him to go find those columns. I don't know if you guys remember any of the demos when strings were not working, but I felt a little embarrassed every time someone had to drop columns that were strings. So I would feel probably the same way if we drop columns that are just random objects. But Charles has a really good argument anyways. So.
Okay, what about, how are we handling things like, say somebody's run a buy, and then you've got array columns at that point. I know the GUI will just display a string summary for the first bit, but that may be some GUI specific thing. What are we actually doing?
Yeah, so it's actually not GUI specific. It's because it's an object, it's calling that toString method, and that toString method has a limit on the number of items that it displays. And that's why you're seeing that behavior. So the question is, do we, should that actually be sent, like if that's a DB array of doubles, should that be an array of doubles, right? And I think, Charles and Ryan and Colin, I think we all agree it probably should be an array of doubles, and that comes at a cost to the UI, whether that's displaying all the data or making the UI run effectively like one last update view to convert a bunch of stuff to strings, for the convenience of the user.
Okay, yeah.
So the alternative is still work. It's just, and it's still the same work. It's just like, who does the work? And we're also thinking about maybe it makes sense for it to be actually like a property of the subscription. So when you create your subscription, you just hit a flag saying, hey, you know what? All the like weird stuff, just make it strings because I'm a visual user.
Yeah, that makes sense. I guess as it is right now, you couldn't have a client connect and get actual data.
In what way?
Well, if you're just sending a string for an array.
Oh yeah, sure, yes, for DB, yeah, for DB arrays, yes.
That garbage they didn't really want.
Yeah, but primitive arrays work. So it's like, I guess the problem is you end up, if you do the buy, you get the DB types, and so yeah, there's a task. I just got to get done,
All right, JJ, Jianfeng, you guys have been quiet. You get all this?
I would say I don't get all of it, but this is not drinking from nearly as wide of a fire hose as Colin's talk, so I've actually been able to glean quite a bit of information from this that's pretty useful. So I'm still not super familiar with the idea of a flat buffer and a proto buff, but I at least understand the basics, so I can get a lot more think out of this just leaving the meeting immediately. So.
Just sounds like a little overcomplicated to me.
Overcomplicated.
Why we have to stack gRPC, Aero and then Barrage together to do something? What's the point? Are we satisfying the usability for performance? Is that the main reason? What is that?
Yeah, I believe the main benefit is intercompatibility with the data science community, right? So Aero is a popular open source project in the data science community, and if we play nice, and people say, hey, Deephaven plays nice with them, it might be easier for us to get our foot in front of other people, or our product, the OSS product in front of other people that way.
The hope is that we get some interoperability for free.
Yeah, I'd say it even a little bit differently. And I think I'm always cautious to use the word open. To the extent that we're moving towards a community license and community versions, right? I think the world of open source, which we're adjacent, wants to coalesce around a few winners rather than have everyone solve similar problems in different ways. And so we're just conforming to that.
I'm really curious to see what the Java client API looks like, how easy it is to use by regular Java programmers.
Yeah, so Jianfeng, there's actually something we've worked on that may be helpful there. So JJ went and looked at the C# and C++ clients and created some examples just so we can get a feel for the user experience. If you're interested, he can share a link to those. They're on my review queue, but that hadn't happened.
Well, to Jianfeng's question, though, to be fair, those APIs are not on top of Barrage, are not related to Aero, and are not using gRPC. I think we're all making the assumption, or the hopeful assumption, or maybe it's a steadfast commitment that those API experiences will be unchanged, even though the underlying technology will change as it moves to OSS.
Yeah, they should really be unchanged, I would expect.
That's our goal.
Yeah, those examples. Oh, sorry, go ahead.
A systems level diagram for this would be really helpful. You know, how everything breaks off with the directionality of the interfaces and whatnot would be really useful.
I think from where I sit in a much more ignorant position than the rest of you, I would hope that 90% of our users barely have to care about this. Hey, there's a transport layer. You don't ever think about the transport layer, so you don't think about it here either. So go to work. And yeah, you're curious and you want to seem smart, so here's the stuff. Or you're in that 10% where it's like, all right, I need to understand the transport layer. I can't get anything done.
Yeah, like in the last 10 years, I've worried about it like 3 times. So it just pops up when something doesn't work.
Yeah, this, even though it's important for everyone to understand this, and very importantly, we think we inherit communities around these technologies that might be quite beneficial to our growth and our storytelling. I don't think this is the leading edge of our reason to exist that the DevRel team will be communicating about. Mm-hmm. Like, oh, here's an example of the use of flight. Like, okay, who cares? It's like, no, hey, you can do some stuff you couldn't do. Sweet, let me do it. Oh, it happens to use flight. Okay, I don't care. You know.
Absolutely. Yeah, and that's actually, I think, why my presentation focused more on, you know, the table API or the table update API rather than Barrage, because Barrage is just like a small extension. It's like the things I think that are useful. Like Amanda, I sent you, maybe you could share with the rest of the team, the example where I've got a live table that is just like a single row, single column variable that I can poke from outside and cause the update to propagate through the LTM. I think that's a really good example that is something that maybe is in the DevRel scope, and you do need to know how the LTM works. But like I think with a small number of examples, I think it's a rare thing people are going to want to do. I think like with a small number of examples, you cover a lot of the things, like, you know, 100% of, almost 100% of what you want to do.
Nate, can you touch on? I think we have a concept of a snapshot, right? In Deephaven.
Yeah.
Any relationship between the snapshot, LTM, and exclusive log?
Yeah.
Or
So
they're totally different things.
Yeah. So there's one operation that's called a snapshot table, which creates a static copy of a table whenever something else changes. And it can be initially configured where the other thing is basically nothing, and it just does a snapshot one time. So that's one type of snapshot that we have. And another is like that there's this API called getSnapshot, which does that thing, the current instantiation of going and fetching data while checking for the clock ticking. So that's I think it might be called getSnapshot.
Construct snapshot.
Oh, okay. I was going to say, okay, yeah. In Enterprise, we have something called construct snapshot query, which is the way that you do it over the wire.
And the purpose of supporting the snapshots is what?
The purpose here is basically extracting data from the LTM without stopping the LTM. Well, not necessarily without stopping the LTM, but it would be a nice goal to not prevent the LTM from ticking. So you want to get a consistent view of a table that is changing behind the scenes.
Right. You want something where it's meaningful, what's going on across rows and across columns, right? You don't want, one value to be from a previous time, the next value to be from a future time, another one from the present, like at least from the point of view of the operation, right? You don't want to deal with your data time traveling on you while you're reading it, right?
So from script session point of view, I'm holding the LTM exclusive lock anyways
worry about it, yeah.
throughout the session, right? I mean, basically, I'm getting all the snapshots.
Not throughout the session.
Not throughout the session.
For each command you run. So if you run a whole notebook, you hold the lock for the duration of that execution. If you run a cell from a notebook, you hold the lock for that cell. If you run a single line on the REPL, then you hold the lock for that single line. And then we release the lock, and everything gets to continue going on about its business and updating all the data structures.
I see. So if I create a table, if I get a snapshot of one table, and just with one command, then the second command, I'm getting a snapshot of another table. But we're not in sync anymore. If there's ticking underneath, and if I do a drawing, boom, I might not get what I expect.
Exactly. But if you've got
it's actually harder than you think. So yes, you could use one operation, one script command to get both snapshots, and then at least you know they're from the same cycle. But if they have different input sources, they might still be out of sync, right? Because all of your input sources are conceivably updating asynchronously because you're fundamentally in a distributed asynchronous environment, right? So for example, some of the examples I gave you yesterday about like a trading system, right? If you've got positions coming in from one table, you've got market data coming in from some other series of tables, there's no guarantee that the ultimate source of that data is in sync. Right? Because, for example, positions might update 100 milliseconds later or who knows, right?
But there's a trick.
And so you have to write a query that can handle that. And we have some tooling to help you with that in some cases, if you need lockstep advancement.
So we can actually join a table that's created on the fly. So that will make the join of the two tables on one command, and that will probably
normally you just join two ticking tables and you look at the results of that, right?
Okay.
So Amanda, you were talking about users seeing this. I think the most likely use case is somebody wants to implement a new open API interface for some new language. They need to know how to do that, but you figure that's going to happen maybe a dozen times. It's not going to happen 1,000 times.
About the Barrage and multi-worker, working together. We're not partitioning the table, right? To send a piece of workload to different workers, and then that's not the case, right?
That's not something that we do automatically, but it is something that you could do. So that's something like our enterprise thing does, right? You could create a worker that has some output that a bunch of other workers might depend on, right? And you could potentially say, oh, I'm going to do symbols like A through F on this worker and G through whatever on that worker. So you could do that manually.
And when he says manually, he means you could separate a table out into subtables using a single table operation, and then send those subtables to different workers, for example.
Ryan, do you have anything to add?
Not unless there are more questions.
Alex, do you have anything?
I don't at the moment.
Right.
I'm excited
Thanks.
to get more table functionality other than just timetables and see how to actually make them.
Indeed, I imagine you are. It's kind of the product feels a little incomplete without that, right?
I would say what you said in regards to more table functionality, I agreed with, and then I heard the last thing you said was including how to make them made me cry a little bit. The literally less than 0.0001% of use cases involve, timetables, empty tables, new tables, or creating tables. It's mostly, hey, there's data in the world, I want to do stuff with it. So, that's where we'll get to once we have some of this data in stuff done.
Kafka, yeah.
Kafka, baby. Woo.
Yeah.
Jeez, Pete. But yes, so the enterprise world, of course, you have extensive ticking data samples already existing, right? Both in our demo environment and in our customers. Here again, we can simulate it the way you were talking about it a little bit, right? Or with update loops like you were discussing with me the other day, Amanda. But once we've got Kafka live, we'll be able to have more demo environments around that.
All right, Pete, do you have anything to add?
No, thank you.
All right. Thanks, guys. Thanks, Nate.
Yeah, thank you.
Thanks, Nate.
Thank you.
Bye, everyone.